Welcome to Metal Casting Lecture Series by Professor Joyjit Ghosh. This is the 11th lecture of a series of lectures. This lecture will be on solidification of sand casting. Chauvirnow's solidification rule will be discussed. Also several examples based the Chauvirnow's solidification rule will also be discussed, so do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this 11th lecture of a series of lecture of metal casting. In this lecture we will be discussing about the solidification of molten metal in the mold. Now it is very important if you are a foundryman to know how the metal actually solidifies inside the mold, and this knowledge will enable you to develop quality casting. So the fundamental to a quality casting is our knowledge of the solidification process of the casting. Although it's a area of metallurgy, we'll briefly go into this without going into the details or into the depth of the aspect of solidification. But a little idea is very important for us to understand about the casting process. So the change from hot molten metal to a cool solid casting takes place in three main steps. In the first step, the cooling of the metal from the pouring temperature to the solidification temperature. It is like this. So from this temperature to the solidification temperature, and this time, this much time is what the foundryman has to fill the mold cavity. Within this time, this is called the superheat. This temperature difference is called the superheat. This is the freezing temperature and this is the temperature of the molten metal. So this temperature difference is called the superheat. So this this much amount of time the foundryman has to fill the mold cavity. The second step is the cooling of the metal through range of temperature. So at constant temperature it will solidify and freezing starts, and actually this stage is basically it's liquid plus solid. This is liquid plus solid, and this is solid. So at this stage at constant temperature we are discussing about pure metals here. So here it will solidify at constant temperature. Okay, so for pure metals it will solidify at constant temperature. So it is somewhat like this here, and after this it will solidify slowly. Sorry, it will cool down slowly. This is the solid area, this is solid plus liquid, this is liquid. And if we plot the density and the time curve here, you can see the density is increasing here. So this is the liquid shrinkage and this is solid shrinkage. So this is compensated by the riser. Okay, so what happens during solidification? So as the metal is poured, the mold wall heat transfer takes place through the mold wall, and a thin skin is formed of the casting, and gradually the grain growth will take place, and the grains are randomly oriented initially, and as the direction solidification starts, the growth takes place towards the direction of solidification, and therefore a columnar structure is obtained in the inner side, and this continues to grow. It forms like a needle. Sorry, this is called dendritic structure. So it will grow like a needle, and this needle will grow branches, and it is called dendritic structure. So this is the skin, and this is the columnar structure of the grains, and this is for alloyed metal. This is equiax structure, and I'll show you. So this is a particular experiment. So after 8 minutes, after 11, 40, 60, 90, 2 minutes. So what happens? A is for grey cast iron after 180 minutes, and B is for carbon steel. See how they are differently solidifying. And you can see this is the dendritic growth, this is the mold wall. So the thin skin is formed and gradually it starts to solidify inside. Okay. Now, a very important formula that we are going to discuss is called Souvrenis rule. Now, it is very important for us to know how much time it takes to solidify. Souvrenis did several experiments, and he came up with a formula that the solidification time, total solidification time, is equal to a constant C, which is called a mold constant, into the volume of the casting by the surface area of the castings to the power 2 or to exponent. It is normally to the n, and n is normally taken as 2. So TST is the solidification time, V is the volume of the casting, A is the surface area of the casting, and n is taken as 2. So I have directly written here 2 here, and Cm or C is the mold constant. And we can find out the value of the mold constant by various experiments, by actually casting and solidifying, calculating the solidification time. Now this formula is very important for us to design the casting. Why? Because we know that the solidification time is dependent on the volume of the casting to the surface area, and if I can increase this ratio, that is the volume by surface area ratio, then my solidification time will increase. And this is very important for designing the casting, getting system, and also the riser. So we'll design the riser in such a way solidification time is more. Okay, so based on this formula, let us solve a particular problem. So in this particular problem, there is a steel casting which is a cube. The mold constant C is 4 minutes per centimeter square. This we know from our previous experience. And the casting is shown in the figure, whose length is 30 centimeter and width is 10 centimeter. And the thickness is 20 mm. So how long it will take for the casting to solidify? So the area will be 2 into length into h plus 2 into w into h plus 2 into w into l, and the volume will be L into H into V. So the area is coming out to be 760 centimeters square. We first calculate the area, then we calculate the volume. The volume is 600, so V by A will be 600 by 760, and C is given to us 4, so it comes out to be 2.49 minutes it will take to solidify this casting. If we discuss one more problem here, it is cylindrical part, so in figure 2, okay, and the radius of the cylinder is 250 mm and its thickness is 20 mm. So, and the mold constant is 2 second per mm square. How long it will take to solidify? So the area will be this area, surface area will be this area, that is 2 pi r square, and the circumference into the h. 2 pi or pi d is circumference into h will be the surface area of this side. Now this area is on the top and on the bottom, so it will be twice pi r. Okay, so volume will be pi r square h. So sorry, not twice pi r. Pi r square is the area of this surface, and 2 times it is, therefore it is twice pi r. Pi d square by 4, had it been pi d square by 4, it would be into 2, so pi d square by 2. So this cross sectional area, the surface area will be this value 424115, and the volume is 3926991 mm cube. So mole constant is given to us. Time taken will be calculated like this, which is coming out to be 2.86 minutes. Very simple problem. So like that we can use the Sovronov's law rule to calculate the time taken. So this is another problem. So in this problem, it takes 155 seconds for a cube to solidify. The cube has 50 mm side. Now you have to find out the cm. Also, if the same alloy and mold is used, find solidification time for cylindrical casting. If it is cube and the cylindrical casting, we know the surface area formulas for both the cube and the cylindrical casting. So we can do it like this. So area for this surface area of the cube will be this, and the volume of the cube will be this. So V by A will be this, and it takes 155. So 155 divided by this square will give you the mole constant, which is 2.232. So this mole, because we are using the same mold, so this will be applied in the next part of the problem. So we'll for the next part of the problem, we know this, so we calculate surface area, which is coming out to be 6126, and the volume comes out to be 35,343 mm cube. So we know this mole constant, so V by A whole square into this will give me the time taken. So the time taken to solidify is 1.24 minutes. So I hope the solidification problems are clear to you. In my next lecture, we'll be discussing about the design of risers in sand casting. Thank you all of you for watching this video.